This is the second page of the 10.2 to 10.5 review worksheet number 1. Number 3 says sketch the curve represented by the parametric equation x equals root t and y equals t minus 2. One thing that we can do is we can pick appropriate t values, and then from there we can plug into the respective x and y values, and then from here we can plot these order pairs, and we can also give a directional indication as to how the curve is and in which direction this curve is moving. So let's look at some restrictions here for t. We know that our t value has to be greater than or equal to 0 because of the fact that we have x equals root t here. So that's the only restriction, that t has to be greater than or equal to 0. So that's our independent variable here. Let's go ahead and start putting in some values. So we'll start at 0, 1, 2, 3, 4. So now we can plug these t values into the respective x and y components. So plug in 0 in for t, we get 0 and negative 2. Plug in 1 in for t, we get 1 and negative 1. Plug in 2, we get root 2 and 0. Plug in 3, we get root 3 and 1, because 3 minus 1. And then finally, if we plug in 4, we get root 4, which is 2. And then if we plug in 4 again in for y, we get 4 minus 2, which is also 2. We can plot all these order pairs. So 0, negative 2, 1, negative 1, root 2, 0, root 3, 1, and then 2, 2. And then from there, we can draw directional arrows starting at 0 and connecting those points. Number 4. An object moving along the curve has position x of t, y of t, and with derivatives dx dt and dy dt. At time t equals 0, a particle is at position 4, 7. What's the particle, or where's the particle at t equals 2? So again, we go back to our equation. Anytime we want to find a given, trying to find final position of a particle or object, we always start with the initial or the given position, and then we find the displacement. So displacement a lot of times is simply just the accumulation of the velocity over a course of time. So we have x and y, horizontal and vertical components. So x of 2, we're trying to find x of 2, and what we're given is x of 0. So x of 2 is simply x of 0. So my final position at 2 is my initial position 0 plus the accumulation from 0 to 2 of the definite integral of dx dt. This will take care of the horizontal component. So x of 0 is 4. The definite integral from 0 to 2 of cosine t squared, we use our calculator, we get 0.461. So 4 plus 0.461 is 4.461. So this is the x value at t equals 2. At the y component, we can plug 2 into the y function. So we're trying to find y of 2. So y of 2 is just the initial. In this case, it happens to be a y of 0, plus the definite integral from 0 to 2 of dy dt. So the change in the velocity component. If you accumulate the velocity component velocity over the course of time, we get the vertical displacement plus the initial position, and that'll give us our final position. So y of 0 is 7, right? And then the definite integral from 0 to 2 of sine of t cubed is 0.452. We add those terms together, those values together, and we get 7.452. So then our position order pair at t equals 2 is 4.461 and 7.452. Number 5, find the arc length. So arc length is the definite integral from a to b of square root of x prime squared plus y prime squared. So if we know this formula, we can just decide which values to plug in. So we first need to find x prime and y prime. So x is root t, so x prime, we go through power rule, which is 1/2 t to the negative 1/2. Y is 3t minus 1, so derivative, go through power rule, 3t minus 1 becomes 3. We plug this into our arc length formula, so x prime, so 1/2 root t quantity squared plus 3 quantity squared. and we can work through this, but most likely we probably want to use our calculator. So calculator will do the work for us, and the arc length or distance of this curve, length of this curve, will be 3.249.